Alright, welcome back. This should be part 2. So we're at this integral here, and I said we could use the tabular method because x squared, if you keep taking its derivative, it'll eventually go to 0. So normally tabular methods work written like this: our differentials and our integration ones. So these ones will all take the derivative, these ones will all take the integral. And you pick the derivative one that goes to 0, which in this case is x squared. And the derivative of x squared is what? 2x. Derivative of 2x is 2. Derivative of 2 is 0. Boom. So got it down to 0. And this one is a little tougher because we had to integrate each term. So we start off with cosine of nx. And what's the integral of cosine to the nx? It is sine, right? Because sine, the derivative of sine is cosine. Yep, so sine, but don't forget there's an n in there, so 1 over n times the sine of nx. That's the integral. And let's take the integral again. The integral of sine would be negative cosine at this point. But there's also n, so make sure we multiply. So now we have n squared in the bottom. Oh, it's negative, by the way. Cosine nx. And then our final integral, the integral of cosine is just, integral of negative cosine is sine. There. And bring out that n again, so 1 over n cubed this time, times sine of nx. Alright, if you haven't seen this method before, it's a really quick method. You'll see how quickly this comes together. And so what we do, plus minus, so the little tabular trick. Oh man, I really smudged this together. That's 1 over n cubed. This pen's quite smudgy. Alright, so and what we do is take these and connect them. This connects here, this connects here, this connects here, and we're going to multiply. So if you haven't seen this method, all we're doing is multiplying here. So x squared times 1 over n times sine nx. Come over here. It's just going to throw x squared in the upstairs. X squared over n times sine of nx. Oh, I'm getting slappy. Sine of nx. And then we want to, looks like we have a negative and a negative, which makes a positive. So plus 2x in the top in the numerator over n squared times cosine nx. Oh, running out of room here. Should have wrote it. And then our last one. Plus 2 over, remember this is n cubed. I just smudged it all together. So plus, I'm going to write it down here. 2 over n cubed. N cubed, hopefully I don't smudge that one. Times sine of nx. Right? Yep. Nx. Awesome. So that is this whole integral here. But without the boundaries, and also notice we have a 2 over pi out front, so let's not forget that guy. We'll put these in big brackets here. And 2 over pi out front. And our boundaries are from 0 to pi. So let's plug in these boundaries. So let's start with pi. So notice, which is really nice, because if you plug pi into sine, and these are natural numbers, any interval where sine is pi is just 0, right? So this would go away. And also this sign would go away. So the only one we're really working with is this guy here. So let's plug this in. We have 2, let's see, so we have 2x over n squared. Oh, it's not x because we're putting that pi in, so 2 pi over n squared. Okay. And times cosine of pi x. Or n times pi, that's what I meant to say, because those x's are turning into pi's. N times pi, which has quite a unique feature there. Okay, so it's going to be all this minus our 0 term here. So you plug in 0 to sine, goes away. Plug in 0 to this guy, notice it's in the numerator, or go away. Plug in sine, so 0, it just goes away. So we are finished with this integral. We can now distribute, and I'll talk a little bit about this cosine n pi thing in a second. So 2 times 2 pi is 4 pi. Well, notice our pi's will actually cancel out. You got one on the top and bottom, so we'll just have 4 over n squared. 4 over n squared. And this is where it gets pretty cool, because what is cosine at intervals of pi? Well, let's think about cosine intervals of pi. So here's a cosine wave, right? And pi is right here, pi is right here. So cosine is interchanging from 1 to -1. It's just an alternating series from 1 to -1. So we can really write that summation as -1 raised to the n, because it's going to be a summation. So you plug in 0, it would be a 1. You plug in 1, it'd be -1. Plug in 2, it'd be a negative. So you can see you go back and forth. 1, -1, 1, -1. So that's a really cool trick right here. And that's here, and that's it. That was the hardest one. And that is our an. And I'm going to square that one. Just so far we got our a0 over 2, we got our an, and all we need left is the bn. And this one may look bad, but this one's probably the easiest one of them all, so let's go for it. So bn states that you have 1 over L times the integral. Oh, I'm off the page here, sorry about that. Let me scoot this way up here. 1 over L, integral from L to L of, let's see, hold on, my camera's falling. I'm on a rickety setup here. Okay. Alright, so back at it. So this one's a sine wave. So sine n pi x over L times our function derived by x. Okay, let's plug in our pi. So we have 1 over pi from -pi to pi of sine. Notice yet again, this pi's will go away, so just nx times our function, which is x squared, and dx. So let's think about this one. First off, sine, what sine looks like. So yet again, symmetric. We can do that same good old trick, changing this to a 0, making this to a 2. Just makes things easier. And now let's take a look. Since it's sine symmetric and x is symmetric, oh, actually, I don't think we could have done that. Let me put that back, because we can't do that. Yeah, because this is -pi. My bad. It doesn't matter anyway, because you'll see what this turns into. Notice this is going to look like, and our sine wave so all this area on the left side is negative, all the area on the right side is negative. So when you add them together, what are we getting? The area is just 0. So this whole thing is just equal to 0. That's we can really just skip straight to that by just analyzing that integral. So that's equal to, so that's as simple. So bn is equal to 0. All right, now we have everything we need to put this puzzle together. So now let's plug it into this Fourier series. Okay, so our Fourier series, which was f of x, is equal to, so our first term here was so pi squared over 3. It's a over 2. Let me keep the Fourier series up here so you can see it. So this is pi squared over 3. And that is that one. So plus the summation, n equals 1 to infinity of an. And what did we figure out an was? This one was a little tougher. An was right here. Oh man, I really smudged this one up. This pen is bad. So this is 1 to infinity of summation. That looks like it just died on me. But our an is, where was our an circle? There it is. So it is 4 over n squared times -1 to the n. All right, and then times cosine. And notice yet again we plug in pi, which we're actually going to plug in pi here. We're not going to plug in x. This is going to be f at pi now. We're going to plug in pi. You'll see why we did that. So we plug in pi here. This just be nx. Okay, and then our last one, which notice bn is 0, so there is no last one. We are done with this Fourier series here. Okay, and so I know it's pretty sloppy. My bad for getting so sloppy. Running out of the other paper too. And what is f at pi? Notice f at pi, f of x is at x squared. So f at pi is just pi squared, right? Pi squared. Man, I'm all over the place. Okay, so I'm going to write this a lot neater. So we have pi squared is equal to pi, what was that? I can't even read my handwriting now. Pi squared over 3 plus the summation n equals 1 to infinity of 4 over n squared times -1 times, what? Check this out. Cosine is at also intervals of pi. Oh, this should be a pi because I plugged in a pi here. Oh, I'm always doing that. So that x is a pi because I plugged in a pi. I didn't plug in an x. I plugged in a pi. So this is n times pi. And what is cosine at intervals of pi, as we discussed earlier? It is the same thing. It's just a -1 raised to the n. So now we have we have -1 raised to the n times -1 raised to the n. Let's think about this real quick. Exponential loss here. State that this is -1 raised to the 2n. So this would be -1 raised to anything that's even. You square anything, or any even, it's going to end up being positive. So this is just going to end up being a +1. So really this just cancels out. Nicely, easily cancels out. Alright, so now we're just left over with this here. And I'm going to turn the page and write it down a little bit neater. And I'll put that in the third part of the video, so I'll come right back.